Did you know that product to sum and sum to product trigonometric identities are essential tools in engineering, particularly in fields such as signal processing, communications, and control systems? I'll provide an overview of these identities and walk through some example problems so that you can learn how to apply them. Welcome to Understand the Math. We've created free guided notes that you can use as you watch this video and placed a link to them in the video description below. There's space in the notes for you to highlight the important concepts and to fill out the answers to the examples that we're going to do. Let's first look at product to sum identities. These identities allow the product of two trigonometric functions to be written as the sum of two trigonometric functions. These identities can be derived from the sum and difference identities as I've shown here. I've listed these identities here for your reference. The left-hand side of these formulas contain products, and the right-hand side contains sums. Let's now look at sum to product identities. Sum to product identities can be derived from the product to sum identities that we just went over and are listed above. I've included the derivation here and on the next page if you want to see the details. I've included these sum to product identities here for your reference. Let's now dive into some example problems so that you can learn how to apply these formulas. In the first two examples, we're going to write the given product as a sum. Our first example is sine 2x cosine 3x. We'll begin by writing down the sum to product identity. Sine alpha cosine beta is equal to 1/2 sine alpha plus beta plus sine alpha minus beta. We'll let alpha be equal to 2x and beta be equal to 3x. This gives us sine 2x cosine 3x is equal to 1/2 the quantity sine 2x plus 3x plus sine 2x minus 3x. Let's now simplify this. This gives us 1/2 times the quantity sine of 5x plus sine of minus x. We don't want to leave it as sine of minus x, so let's make a note that sine of minus x is equal to minus sine of x, and we'll plug that in. This gives us an answer of 1/2 times the quantity sine of 5x minus sine of x. Converting a product to sum like this is used a lot in calculus problems. Our second example is cosine 37.5 degrees times cosine 7.5 degrees. Our product to sum identity is cosine alpha cosine beta is equal to 1/2 the quantity cosine alpha minus beta plus cosine alpha plus beta. We'll let alpha be 37.5 degrees and we'll let beta be 7.5 degrees. Let's now plug this in. We have cosine 37.5 degrees times cosine 7.5 degrees, and that's going to be equal to 1/2 cosine of alpha, which is 37.5 degrees, minus beta, which is 7.5 degrees, plus cosine of these two added. So 37.5 degrees plus 7.5 degrees. This gives us 1/2 times cosine of 30 degrees plus cosine of 45 degrees. This then becomes 1/2. Cosine 30 degrees is root 3 divided by 2, plus cosine 45 degrees, which is root 2 divided by 2. This gives us a final answer of root 3 plus root 2, all divided by 4. If you do enough of these, you'll really start to get the hang of it. In our next two examples, we'll write the given sum as a product. Our first example is sine 5x plus sine 3x. We'll begin by writing the sum to product identity, sine alpha plus sine beta is equal to 2 times sine alpha plus beta divided by 2 times cosine alpha minus beta divided by 2. We'll let alpha be 5x and we'll let beta be 3x. This gives us that sine 5x plus sine 3x is equal to 2 times sine, and we'll add alpha plus beta, so we have 5x plus 3x, and divide that by 2, and then we multiply it by cosine 5x, and then we'll subtract 3x and divide all of that by 2. This gives us 2 sine 4x times cosine of 2x divided by 2, which is just cosine x. Our last example is cosine 255 degrees minus cosine 195 degrees. I've included this example because it's more complicated and we'll need to use a reference angle. Just like we did with the first problem, we'll start with our sum to product identity. We have cosine alpha minus cosine beta is equal to minus 2 sine alpha plus beta divided by 2 times sine alpha minus beta divided by 2. Our alpha is 255 degrees and our beta is 195 degrees. Cosine 255 degrees minus cosine 195 degrees is equal to minus 2 sine. Now we'll add our two angles. So we have 255 degrees plus 195 degrees divided by 2 times sine of 255 degrees minus 195 degrees, all divided by 2. This gives us minus 2 sine 255 plus 195 divided by 2 gives us 225 degrees. And then 255 minus 195 divided by 2 gives us 30 degrees. So we'll multiply this by sine of 30 degrees. 225 degrees is in quadrant 3. So our reference angle is going to be theta minus 180 degrees. So let's make a note that our reference angle is theta minus 180 degrees. So this is 225 degrees minus 180 degrees, which is equal to 45 degrees. And we know that the sine of 45 degrees is root 2 over 2. The sine function is negative in our third quadrant. So that means our answer is going to be minus 2. Sine of 225 is going to be minus root 2 over 2 times sine of 30 degrees, which is 1/2. We have a lot of 2's going on here. Let's see. One of them's going to cancel. And our answer is going to be root 2 divided by 2. I have a video on how to find reference angles if you need to brush up on that. I hope that you now feel more comfortable with product to sum and sum to product identities and feel ready to do some of these problems on your own. If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.